Thank you very much for coming. Really appreciate that. And thanks to Vladia for being agreeable on giving a talk on his two recent papers that were published last year.
Last year, right?
Yes, about non-invasive diagnostic of invasive bacterial and fungal diseases, if I can remember correctly. So the floor is yours. Thank you very much.
Thank you very much for coming. And I will show you today these two papers. So the first one is dedicated to urinary tract infections. It's a collaboration between our institute and ICEM here across the street. And in this study, so we were given the task to distinguish invasive or acute pyelonephritis, which is the inflammation of the kidney, from acute cystitis, which is the inflammation just of the urinary bladder. Yeah. So the task was to distinguish these two diseases or stages. And so far, the current diagnostics relies on the CT scanning, which is a tool which is very good, but actually gives no information about the microbe which is there, about the extent, about the resistance. So yeah, therefore we started with this project some 3 years ago and build up this patient sample cohort that consisted from 95 patients, and these were divided into these 3 major cohorts. So the biggest was a control cohort, 44 patients who were culturally negative. The other cohort was patients with acute cystitis. These were 28 rather young women who were the inpatients admitted for the care in Krč Hospital. And then we had this cohort of acute pyelonephritis and complicated UTIs. So this cohort was 23 patients. And these people were admitted for the intensive care. So they spent several days at the ICUs here in Krč and were suffering from those mono infections or polymicrobial infections. You can see that the dominating agents here were E. coli, Klebsiella. This was in this complicated UTIs group as well as in the acute cystitis group. So with these 3 cohort patients, so we are doing classical microbiology. Culturing is the golden standard here. I must tell it's a golden standard, but the sensitivity is very low actually, especially in cases where you have a polymicrobial setting. And then we are doing the analysis of microbial metabolites by our tools, which is mass spectrometry. We were specifically looking for the metallophores that are secreted by Enterobacteria. So you can see the structures here. And in parallel, we are also doing these enzyme assays, immunoenzyme assays on lipocalin-2, pentaraxin-3, and ceruloplasmin. And all these tests were done on urine. So the whole study is non-invasive study on the urine samples. Here are the results. So I will start with the acute phase protein biomarkers. So these 3 molecules are human acute phase proteins that are secreted and excreted to urine at higher quantities when there is an infection episode. So when you compare the levels from the control through acute cystitis up to acute pyelonephritis, so you can see in all 3 cases, so there is an increase in the concentration of all those 3 biomarkers. And out of these 3, so we selected specifically lipocalin-2 as the best behaving biomarker because there is that biological connection the lipocalin-2 is trapping enterobactin. So it's a textbook example of innate immunity. So this one we actually selected as the best performing biomarker for recording the host response to the infection by enterobacteria. The second layer in is diagnostic testing. So it was the measurement of total metals, and we selected zinc, iron, and copper. And to our surprise, the best behaving biomarker was copper that could even distinguish this acute cystitis from acute pyelonephritis. With iron and zinc, the statistical differences were not significant. So when, if I want, yeah, so this slide is to show how actually it works in a real setting. So when you have a control patient, healthy individual, so there is some basal concentration of copper ions in the urine and also some basal concentration of lipocalin-2. When you have acute cystitis, that means the bladder is hit, so the copper goes up, so it's a response of the host to the bacterial invasion. Copper ions are toxic for the bacteria. And the second response is here via lipocalin-2, so the concentration of this mammalian scavenger, protein scavenger, scavenging bacterial enterobactin goes to 20 picomolar concentration. Even higher concentrations were recorded in the case of pyelonephritis and complicated UTIs, in which you also have kidney hit by bacteria or the ureters are hit. And in this case, so we see these really high concentrations of those two biomarkers, which is total copper and lipocalin-2. So when we translate this into analytical chemistry, so by combination of these two biomarkers, we received a test that has 78% sensitivity, which is quite good for this setup, and quite low specificity. But still, this is something which is quite significant for the UTI clinical chemistry, as we were told. When we add to this setting also the fungal or the bacterial Siderophores, so we even can improve the sensitivity, but at the expense of specificity. So what we learned from this study? So actually, for the first time in our mass spectrometry laboratory, so we could see two responses of the immune system, I mean, at the level of innate immunity. So copper is a great player in bacterial infections here. And lipocalin-2 is it's a great diagnostic biomarker for those infections that are actually displayed through the secretion of enterobactin. So this is on the host side. And on the pathogen side, so we see there is for enterobacteria, there is a diverse spectrum of metallophores. And if the bacterium secretes just the enterobactin, so with that, the host can cope quite well. But if it is able to secrete also aerobactin and Yersinia bactin, then there is a problem for the host. So if we now do these conclusions for this particular study, so there is a recommendation for UTI clinical chemistry or clinics in general. So if you have a negative non-invasive test with people who have this UTI infection, so you can, that means you have just cystitis, So continue with the prophylaxis and simply wait and see. But when our test, which is the combination of copper plus lipocalin, when it is positive, so then invasive sampling is necessary. That means the direct sampling from the kidney. So do this invasive sampling and then antimicrobial susceptibility testing and change the therapy. So I would like to stress here that in our cohort of all these patients were immunocompetent, so we could really see that lipocalin 2 and copper innate immunity layers are active and they work. But all the episodes with aerobactin and Yersinia bactin, so these were the episodes or the patients who actually were accepted to these ICUs. Yeah. So with those patients who had bacterial strains or who had infections with bacteria that are that have capacity to secrete aerobactin and Yersinia bactin. So against those molecules, we don't have any active protection through lipocalin 2 or any other scavenger, and therefore we have a problem. Yeah? So this is for the first paper. The second paper is related to the fungal infections, and contrary to the first one, so this was a fatal case. Again, we learned some biology here. This lady was admitted to the ICU in Ostrava Hospital I think 2 years ago. So she was a neutropenic patient. And actually, the primary diagnosis was that she had pulmonary infiltrates in both lungs. And from the induced sputum, the primary diagnosis was that there is Aspergillus fumigatus because of the DNA found in this sputum sample. So the whole case was started, the treatment started as an invasive aspergillosis in a hemato-oncological patient. And the first treatment which was selected, so it was caspofungin, which is an empirical treatment. And this first layer of the treatment was not so successful, as you can see from the levels of serum galactomannan, which is a biomarker for invasive aspergillosis, and serum beta-glucan. So all these, or both biomarkers, were simply much above the thresholds for the invasive infection. So soon the physicians switched the therapy to a much stronger voriconazole, which is now fungicidal, not just fungistatic, but this is fungicidal. And you can see that even during these almost 10 days, so there was actually no good response to this therapy. You know? The only indirect criterion that something simply is happening here, so these were these neutrophil and leukocyte copy numbers. So during these first 14 days, so there was a chance the number of those cells was going up or was constant, but from this point, which is like a turning point, day 14, so these copy numbers went down and all was wrong. So that was actually the suspicion that there is some hidden player, some cryptic species, and that was really shown by additional sampling of the sputum, which was done here on the day 18. And in the sputum, so there was, in addition to Aspergillus, so there was a second fungus called Rhizopus mycosporus found in the sputum. So again, they immediately switched the therapy to amphotericin B, to which Rhizopus, which is the mucormycete, is sensitive. And based on that, so you could see some really slight decline in galactomannan, but the patient was worsening. At the end of the stage, she received isavuconazole, but yeah, it was too late. Finally, the patient was released from the hospital on her own request, and she died in a week at home. So what we could do better here? The CT, again, in addition to these neutrophil and leukocyte profiles. So that was actually the second only the second tool which was giving some useful information. So in this case, you could see that actually all is wrong, and there is this huge, several centimeter large bird nest in addition to these infiltrations which were everywhere. Yeah. So on the day 18, it was apparent that we lost the patient. So in this case, this patient fell into a study we have on AZV grant. So it's a large grant that collects prospectively the patients that are in risk of these invasive fungal infections. So we could record prospectively those patients, and specifically in this case, with some delay, half a year delay, we could learn what was actually happening there. So one of the biomarkers we are testing here, so this is the serum pentraxin 3, which is a acute phase protein that recognizes galactosaminogalactan of the fungus. So it has some specificity towards Aspergillus. And the profile over this 1 month course at the ICU, you can see that the first 2 weeks were actually rather okay. So these concentrations are reporting to like a chronic fungal infection. But once the concentration jumps up to 5,000 picograms per milliliter, so this is a triage criterion, and here we see that we are actually losing the patient. In addition to this pentraxin, which is a host factor, so we were recording the Siderophores in the urine. So now we are switching from serum to urine. And you can see how quickly, for example, Aspergillus acetylfusarin C is reacting to the antifungal therapy. So in this case of caspofungin, which is just fungal static, so we see a reduction of these indexes, 16 to 4. So it was not completely cured or solved. Contrary to the effect of voriconazole, which is fungicidal. So the index dropped from 17 to 0 in this case. So if that would be the end of the story here, so the patient would survive. But there was the cryptic player who actually was helping Aspergillus to survive these bad times. And Aspergillus very quickly in these 2 days, so it's between Tuesday and Thursday, so these were the sampling days. So the Aspergillus quickly returned and then continued its work. So the cryptic species here was the Rhizopus that could be detected very early, actually, in the urine if we know the approach, if we know the procedures. So actually, here we could save the patient if we have this diagnosis in place earlier. So against the Rhizopus, as well as against Aspergillus, so amphotericin is active, but at that time the fungal wall was too big. Actually, the biofilm simply was completely resistant, and here the patient was lost. So what could we learn from this specific case? So thanks to this prospective setup of this study, so we collected 80 tests, and we could somehow reconstruct the whole fate of the patient during her 1 month stay. So what we learned, so serum galactomannan and serum beta-glucan were constant or even declining during the course of the stay. So these were false positive results, or false results. So actually these these biomarkers that are so far generally accepted, when they say that they were declining, so opposite was true. The patient was worsening. So that is negative, yeah. But what actually we like and appreciate here that correct diagnostics was made from the invasive sampling, which was the DNA in the induced sputum, which is very good approach, but the patient must be sampled. And this is something you can't do every day. And you can't do it on ventilated patients. You can't do it on many patient types, kids, etc. Yeah. What I like here actually is that we could rely on the neutrophils and leukocyte frequencies in the serum, because in this case, they really reflected the real status. Yeah? When the copy numbers of those cells were enough, so the patient was still in the game. Once they started to decline, even despite specific treatments and additions of those cells to the patient, so then the patient was lost. So we know that actually neutrophil and leukocyte influx is a driver. So we can take one or two, maybe more, host proteins that are secreted by neutrophils and by these leukocytes and use it for diagnosis. And specifically, we are looking for something, for some biomarker that is more specific towards fungi. Yeah? And this is pentraxin 3. Yeah? So as a result of this study, so now we are using this pentraxin 3 as a triage criterion in the future studies. We also learned that Siderophores quickly reacted to the antimicrobial therapy. This I showed quite clearly. So contrary to galactomannan, that has a huge delay or even false result, so Siderophores are immediately reacting in minutes, actually. Yeah? So this we know from animal models. And yeah, complicating issue is that again, Staph C or Triacyl fusarium C or Rhizophorine, we don't have, or so far we don't know about any active mammalian scavengers that can do the trapping work similarly to lipocalin 2 against bacterial siderophores. Yeah? So we don't have this line of innate immunity. And maybe that's also one of the contributors why we, in neutropenic patients, we have very high mortality, which is between 50 to 80%. Yeah? In this case, we also learned that these two fungi can actually coexist. We even suspect that they not just coexist, but they collaborate, and that in the result, actually, they can exert higher pathogenicity compared to a situation if they are working alone. So the sum of two mono-infections is lower when they work together in consortium. And on this, we are building the proposal, which I still have not submitted. So these were the people who were involved in the collection of the specimens here. And now the very last slides. So I want to reward you here and show you some work which is very close to the submission. And this is the collaboration we have with Leuven, where there is a huge hospital that has a very large collection of specimens they collected from 2018 to now. And during specifically the COVID time, so they collected many patients, many hemato-oncologic patients that had these fungal infections. And they collected also the urines. So that this is something very specific, because in our hospitals, some hospitals are even not storing endotracheal aspirates. But this hospital is storing everything, and they really have a huge biobank. And they approached us and asked to run urine samples of their patients. Actually, the story is that they wanted to show some their biomarker, which was a protein, some glycoprotein derived from Aspergillus, and they believe that simply that this non-invasive detection would work, which was not the case. But when we had this several hundreds of samples, in this case, you can see that we were running really a large number of samples. So we did our study, and we checked our Siderophores and pentraxin 3 on this. So we did this design of the study, and actually from this work, so we suggested an improved protocol or recommendation, clinical recommendation, how to make the analysis in these hemato-oncologic patients. So the protocol is based on a non-invasive approach. So we are analyzing just serum and urine, nothing else. If you have positive finding of the metallophores in the urine, so immediate there must be the treatment and all the machinery associated with those neutropenic patients, because those patients are at extremely high risk. Or if they have positive serum galactomannan, so this is another feature that actually takes or sends this patient to immediate special therapy. If those two biomarkers are negative, so there is a triage step, which is serum pentraxin, which gives another layer of confidence and increases the specificity and sensitivity of this setup. And if serum pentraxin here is positive above some threshold, so again, those patients are sent to intensive therapy and special treatment, and specifically for invasive sampling, because then it's a life-threatening situation. All these three biomarkers are positive, or at least one of them when it is positive, so the invasive sampling must be done. But if these three biomarkers are negative, so then you can keep your hemato-oncologic patient safe at the ICU with no invasive sampling treatment or sampling or simply handling. Yeah. So yeah, that's it. Thank you very much for your attention.
Thank you very much, Vladia. I could understand something.